Okay.
So today agenda uh, is to cover HDFS shell commands. So in this module, we're gonna see that how do we do operations on the HDFS, which stands for Hadoop Distributed File System. But before we do any kind of operations, we should know what kind of file system we are talking about here. We know various physical file systems like ext2, ext4 on Linux, NTFS, FAT32 on Windows. And HDFS stands for your Hadoop Distributed File System. So before you do operation, you should need to understand what kind of file system you're talking about here. Are you talking about any kind of a physical file system like just now I mentioned few names, ext2, ext3, NTFS, or FAT32, or are you talking about some kind of a virtual file system? So we need to understand that first, and then we are going to perform the operations on that file system, HDFS, which is your Hadoop Distributed File System. Okay, so just 1 minute. So we are going to do operation. So as I've explained, HDFS stands for your Hadoop Distributed File System. Just to revise that when you talk about file system, so you have physical file systems, and you can also have a virtual file system. Physical file systems like you have ext2, ext3, ext4. These are the Linux file system. You have NTFS, FAT32. These are your Windows native file system. So what kind of file system we are talking about? And then we are going to see, we are going to perform commands. So basically we are going to use the command line client to perform operations. And in the development section, we will see how to use the Java client, or in other words, how to programmatically access HDFS. So right now, since it's an administrative activity, I will not take you through the Java things, and we will be using the command line client. Or using the command line, we are going to uh, uh, perform operations on the HDFS. Okay, so let us bring up our cluster first. So I will start my Ambari server as well as both the machines where I have installed Ambari server and my HDP. Let it start, and then we will cover few points, and then we'll start the Ambari. We'll start our cluster, and then we'll do the operations. So HDFS, the very first thing you need to understand, and before I go ahead, I want to make sure that you understand this thing. When you talk about Hadoop, you talk about two independent frameworks. The two independent frameworks are known as storage, which is also known as HDFS, and the second independent framework is the computation, which is known as YARN. And YARN stands for yet another resource negotiator. So, and this storage, which is known as HDFS, is managed by three processes, namely name node, data node, and the secondary name node. The name secondary name node is a misleading. Even if you not run it, so these two things are okay to run if you want to access HDFS. Yarn is managed by your resource manager and the node manager. Now, since you are doing an operations, or since we are specifically talking about HDFS or HDFS operation, it is okay to shut down or not to run these two processes altogether. For doing operations on the HDFS, it is sufficient to run only these two. Secondary name node has a different purpose altogether. You run it or don't run it, it will not affect your HDFS operations. Okay, so I hope this part is very much clear that if you want to do an HDFS, if you want to do operations on the HDFS, you don't require to run resource manager, node manager at all. There is no role of these two processes. These are two independent frameworks. The word independent, I hope the word independent is clear to everyone. When you say that Hadoop is composed of two independent framework, that means either you can use Hadoop as a storage, that is only for the storage. You can use Hadoop only for the computation, or you can use Hadoop for both. Right now, I'm using for this exercise. You can very well stop your uh, uh, computation or the yarn framework. You can just on your HDFS, and you will see that you will be able to do the any operations. So this is very important to understand. You should not say that when you are doing HDFS operations, you are thinking about resource manager, node manager. No, please don't think about HDFS when you're talking about HDFS. Don't think about resource manager and node manager. Okay, and name node, everyone knows it's a master process, and master process has two properties which by this time you should be knowing it, that it's a spark and this spark means single point of a contact, and spark means single point of a failure. Spark, you mean when you mean that, what do you mean by spark? A single point of a contact, which means that any operations you do on the HDFS, it has to go through the name node. If it's the spark, which is a single point of a failure, which means that if this name node process is down, then you will not be able to do any operations. Are you guys there?
Yes, Som.
Yeah.
Just mute it so
Yeah.
that there is no voice.
Okay, great. So HDFS. So what kind of file system we are talking about? HDFS, as I've just explained a couple of minutes back, we need to understand that though the word has a file system in it, but what kind of file system we are talking about? We are talking about a layered or a virtual file system which does not modify the underlying file system. Okay, the underlying file system could be any physical file system like ext2, ext3, it could be ntfs, it could be fat32 or whatever. The underlying file system could be anything. Okay, and it does not modify the underlying file system. It's a virtual file system, and this virtual file system is accessible only when name node, data node process are running. I can make it as a secondary name node, but star mark, it is not really required. Okay, it's a star mark I'm putting it. Even if it is running or not running, it is not going to affect your operations. But these two things are very important. That HDF to access HDFS, you have to have these two processes up and running. The HDFS is accessible only when the processes are running. And please understand that uh, it gives you the HDFS. You know that we are talking about cluster, right? We are talking about cluster. So this HDFS gives you the unified capacity. It will not show you the capacity from the individual machines. It will show you the unified capacity. For example, and how does it calculate unified capacity? Is DFS dot data node dot data dot dir, the value you give it, right? Some value you give it, that where do you want to create it. So you give some values, let's say mnt ebs 0. In this, the same configuration file you have given mnt ebs 0. I'm just saying mnt mount point, basically mnt ebs 0. Here also you're giving MNT EBS0. Let us assume the mount point, the hard disk, external mount point or the hard disk, you can say it is of 1 terabyte here, it is of 2 terabyte here, it is of 4 terabyte here, it is of 1 terabyte here. So the HDFS unified capacity will show you 1 plus 2 3, 3 plus 4 7, 7 plus 1 8. It will show you 8 terabyte. So, and also, please understand the HDFS storage capacity is calculated from the data node machines, not from the master machine. That's why I have kept it aside. The HDFS is always the storage, HDFS storage capacity, HDFS storage capacity is is calculated from data node machines. And in fact, now you understand from where it has been, from where it is calculated, from this particular property. What is the value of this property, right? So where you have created, where this particular directory has been created, and what is the capacity there. From there, it calculates the storage capacity. Okay. Now, so HDFS. What happens when you put a file, and we have already seen in the uh, introduction module that when you put a file, the file gets broken into blocks, replicated, and the replicas are physically distributed across several machines. I hope that part, that thing is clear. Yeah. So you need to
Yes.
understand that replicas are physically distributed, or replicas are physically stored by the data on machines.
So I have one question here. When we say that file gets like into chunks, into blocks, is this done by the HDFS itself or by the client who is trying to put the data into the HDFS?
Let us answer this question at the end when I'm going to cover
Okay,
how does the reading and writing happens. That how
okay, okay,
actually who actually breaks the file, whether it's a framework who is breaking the file, or as you said, the client who is writing the file, he's breaking the file. To we'll discuss at the end of this. We'll discuss not in this module, but in the architecture module. But to answer your question, it's just answer your question. It's not the framework who breaks the file. It is the client, or it is the guy. It is the one who is writing the file onto HDFS. He is breaking the file. And the
okay,
further details I'll be giving you in the next module when I'll be covering the architecture of the Hadoop along with the reading and writing operations.
okay.
Yeah?
Thanks so much. So, yeah, thanks so much.
Yeah, okay, just 1 minute. Okay. Yeah. Um, Now, here my question is, what does the client see on the HDFS? As you have just now explained that a file gets broken, replicated, and distributed across several machines, and the replicas are physically stored by the data on machines. And data on machines are also referred to as the slave machines. And please understand that the replicas are not stored by the master machine or the name node machine. Okay. What does the client see on the HDFS when he puts the file onto the? What does the client see on the HDFS when he puts his file? So since it is broken into blocks, so will he see blocks or will he see a file? And to answer this question, you can take the example of a Google Drive. The Google Drive is a classical example of your distributed file system. And when you put anything onto the Google Drive, the file, whatever file you put that gets broken replicated, and distributed across machines. But what do you see on the Google Drive? You see your single file, not the blocks. Similarly, when you put your file onto HDFS, you will not see any blocks, anything. When you see HDFS, you will see your single file, whatever file you have kept it. That you will see. That's what I wanted to bring this point because now we are in. I'm telling you about the details, how that the file gets broken. You should not be under the impression that when I will see the HDFS, I will see various blocks and everything. No, you will see only the single file. Think about the client perspective, the one who is not into Hadoop and all. And if you show him the HDFS and if the files are broken, and if you see blocks and all, he will say that where is my file boss? How will I make out that which part of which block is belongs to my file and all? So please understand that when you put the file on the HDFS, you will see only single file. But behind the scenes, that single file which you see on the HDFS, that is made up of blocks. But also, since I have explained you that if we are talking about virtual file system, so the word virtual means that nothing exists. So please, so whatever you see on the HDFS, it does not exist. It does not exist physically. What exists physically is only the replicas, which is stored by the data machines. So whatever you see on the HDFS, it does not exist. The blocks are physically stored on the local file system of the slave machines. The slave machines are also known as data node machines. And master machine will store the metadata. And if anyone asks you that if the master machine stores the replicas, no, it only stores the metadata. And don't try to find the file names or directories which you see on the HDFS on the local file system. Now, or I would say, when I say local file system, I would should say that on your physical file system, don't try to find it out, because just now I've explained that only the replicas are physically associated, right? So these replicas will be physically associated. You should not try to find out foo.txt on any of these machines. You should not try to find it out, because this foo.txt exists only in the virtual file system, and on the virtual file system it does not exist anything. So you should not find it out. Only these replicas are physically associated, and the name node knows through its metadata information how which all blocks belongs to which file node. So the name node's metadata knows. The name nodes maintain the metadata through which it comes to know that given a file, how many blocks it has been broken into, and which all data nodes are hosting the blocks, something like this. So if you see this here, I'm just trying to explain you that name nodes maintain this metadata with him, that given a file, any file, let's say foo.txt, it has been broken into two blocks, b1 and b2, and b1 is hosted by a data node whose IP address is 0, data node whose IP address is 1, data node whose IP address is 2. b2 is hosted by machine 1, 3, and 5. Yeah. So this metadata is maintained by your name node. Okay. Now coming back to your home directory, HDFS, though it's a virtual file system, but it does supports the various concepts of your physical file system. And one of the concept is the home directory. Now, when you log in onto your machine, so you will always have your home directory. For example, if you have logged in as a EC2 user, so it will have home EC2 user as your um, home directory for the EC2 user. Similarly, on the HDFS, it has a notion of having the home directory, but understand here the notion of the if you see it's a slash home slash username on your physical file system, here the home directory is a slash user slash username. So training user, he is a training user on his physical file system. The home directory would be home slash training. But on HDFS, if you want to have it, the home directory, if you have to have the home directory of your training user, it would be slash user slash training. Okay. Slash home slash EC2 user, it's basically mapped to file colon triple slash. The file colon triple slash is a protocol for your local file system or the physical file system. Similarly, user training, the protocol is HDFS, but it is HDFS colon slash slash whatever the host name you have given colon 54310 slash user slash training. In other words, fs.default.name slash user slash username. So that's your home training. User training, it will be the home directory of the training user on the HDFS. Similarly, if you want to create the home directory for a dev user, it would be slash user slash dev. Now, before we go, let us understand a couple of more concepts. Accessing the HDFS to the command line. Remember, it is not a regular file system. Yes, we know now that it is not a regular file system. We are talking about virtual file system, and this virtual file system is accessible only when your processes are running. Name node and data node specifically, those processes should be up and running. And for doing the operations on the HDFS, you need to use Hadoop FS minus. You need to use say Hadoop FS now, or you can always say, or you can also say HDFS DFS. minus whatever the operation, minus or whatever the operations you want to do it. Okay, it does not support all the Linux commands. So as I've explained you that HDFS is a virtual file system, and it supports most of the concepts of your physical file system, and you should be under the, and you should not be under the impression that it supports all the Linux command whatever you know. No, it supports only few Linux commands, and one of the important command which you always look out for is the editing the file through a VI. So understand, you don't have any files, you don't have any kind of an operation which you can do to edit the file on the HDFS, which means that once you put the file on the HDFS, it becomes a read only. You cannot edit.
I have a question. Yeah, so like there will not be any case like where we will have to really edit the files which is there on the HDFS. Always it will be read only.
What did you say?
Yeah, I was asking like is there any case of where we will have to edit the file on HDFS?
Of course,
Always it will be
there
read
are a lot
only.
of cases. But when the Hadoop
Okay.
was designed, Hadoop was never meant to design updating the file, right? If you remember the
Yeah.
history or the philosophy of the Hadoop, Hadoop was always meant for crunching the historical data. So 50 years of
Okay.
historical data, if you want to change it, I hope no one wants to change the historical data at all. So it was never meant to change the historical data. The one of the reason is that's why they have not supported the VI command. That's one of the reason. Second reason I will explain you right now.
Okay. Thank
Okay,
you.
there are various scenarios where you would like to update the data, but Hadoop is not meant for updating the data. So in Hadoop, there are no random writes. You cannot do any random writes. You can only do appends. Appends means at the end of the file. Okay. Now, to understand that concept, let us go back and let us understand this concept. Um, Assuming you want to keep a file, you want to put a file on the HDFS, and the file size is 1 terabyte, and the block size is 64 MB. When you want to break the 1 terabyte into 64 MB blocks, if it will be near about 14,000 blocks, and let's say the replication factor is 3. This is B1 block, all the 3 replicas. This is V2 blocks, B3, B4 till B14,000. So near about 14,000 blocks will be there if you are going to break a terabyte of data with a 64 MB block size. Replication factor 3, so these are 3 replicas. Okay, now you want to add a one line. You want to add a one line. So you will be adding another, since all are replicas, you will be adding here. And understand that HDFS does not support the notion of having a variable block size. HDFS does not support variable block sizes for a given file. Variable block size for a given file means for a single file, all the blocks will have to have the same size. So you cannot say this will be 64 MB, this will be 120 MB, this will be 34 MB, this is whatever. It has to have a 64 MB. Yeah. Now, since if you want to add one file, it will be it will you will change you will change in these three because they are replicas. Since it supports only the fixed block size, so the overflow has to go to the next block. Overflow has to go to the next block because this is also popular, this is also full, this is also full, this is also full. So overflow has to be popular next block, next block, next block. Essentially, if you see, just by adding a one line, you are going to change the entire terabyte of data because you are touching all the 14,000 blocks. That is very cumbersome operation because writing is a very cumbersome operation, and it is easier to add another block of data at the end. And that's why I have made the statement that no random writes are possible in HDFS. You cannot do random writes. Random writes means you cannot write anywhere you want. You can only do appends. You can only append the data at the end of the file. So the two reasons are, one is the philosophy, one is the history of the Hadoop, that it was never meant for working. It was never, because when you work on the historical data, it was never meant to be changed. So that's one thing. Second thing, if you do, if you provide the VI or additional file, this problem can come up. Okay, so that's why they only support the appends. The last bit is, when performing the operations, while performing operations, if explicit path is not specified, then the operations are performed relative to the user's home directory on the HDFS, related to the user home directory on HDFS. And we know user's home directory is always on HDFS, it is user, so slash user and the username. That is the home directory of the HDFS or of any user on the HDFS. Of any user. Username you can replace with whatever user you are using. Okay, so let me just, I have already started my machine, and Apache Ambari. What I will do here, okay, I can.
So, what is the difference between Hadoop and HDFS? You said we can invoke that FS either through Hadoop or HDFS.
It's an older version, Hadoop FS. There is some reasons. Hadoop FS can be used with the local file systems also. HDFS DFS work with your HDFS file system. Hadoop FS can be work. It can be, you can use local file system as well as HDFS, which is your uh, uh, virtual file system. HDFS DFS, you can only access, you can do operations. HDFS DFS, you can do operations only on HDFS. Okay, one and the same thing, so don't worry about that.
Okay, thanks.
Okay, and let me start my service. Ambari server start. Okay, we have configured to run the Ambari server. As soon as the machine starts, it's already running. I just need to go to this machine, and then I just need to open my Ambari and start my cluster. Username admin, password admin, and I have used 8080 guys, so don't forget that port. All are red. Here you can, all are red. That means I have to start all the processes here, right? You can choose an actions here on your left hand side and say start all. It will ask you for the confirmation whether you would to start all the services. You say confirm start, and it will take some time to start your processes. Meanwhile, I can go here and check my Hadoop FS. That's what I have told you, that only couple of operations are supported, and you can find it out by using Hadoop FS. So just run the command Hadoop FS. It will display you the list of the operations. I'm just minimizing it. So when you say Hadoop FS, these are the only list of operations you can do. Okay, so these are the only list of operations. So append to file, cat, change group, checksum, chmod, chown, change ownership, copy from local, count command, cp command, snapshot, create snapshot, delete snapshot, df, du, expunge, find. These are the only couple of commands. mkdir for creating a directory, ls operations. Yeah. Also, you can do HDFS, DFS. That will also display you the same set of operations. You can see that. The same set of operations are also available with HDFS, GFS. Okay. Let me just see whether all the services started or not. Okay, it's 63%. You can click on here on the right triangle. You can see that triangle, and you can click here and you can see that what's happening. It's starting the node manager start. Okay, so if anything goes wrong, it will print up the logs. It automatically creates all the users. So you can also say sudo su minus HDFS. So you are in the HDFS user. So HDFS, DFS, same thing. And DFS minus LS, I am doing an operations, an LS command on my root directory of HDFS. So it is all these things are there. Okay, so my HDFS has already been started. So that's why I was able to run this, because okay, something has gone wrong. What is that? What's happening? Because it is showing me red. 100%. Okay, now it is green. Right. And I can click on my HDFS, quick links, name your UI. It will bring up my UI. Okay. Other thing, what you can do here, you want to see the HDFS. So you can click on the utilities on the top ribbon. Click on the utilities. You say browse the file system, and that will take you to the HDFS. Right now, you see here it's a slash, and on the slash, that's your HDFS. On the root directory of HDFS, you see applogs, HDB, mapred, temp user. Who is the owner? You can see who is the HDFS, who is the group, which group it belongs. You can see. Okay, but before, I just want to explain here. When I say ls forward slash, this particular operation which you are doing, it's on local file system. It's on physical or I would say your local file system. It is, which means that you are not doing this operation on HDFS. I hope that is clear, right? Similarly, but how do I know that I am doing the operation on the HDFS? I should either append my command like this, HDFS, DFS, and whatever, or you say Hadoop FS, This means that this means that you are doing operation on HDFS. When you do an ls forward slash, you know that you are doing this operation on your local file system. And on your local file system, please see that you have a lot of these many folders. But on HDFS, this is different. So these are two different file systems. Okay. And don't get confused with the USR and USER. US, as I've explained you, the home directory of a user. On the HDFS, it starts with user and the username. What is the home directory of this particular guy? It's if you do a PWD, it's a home EC2 user. It starts with the home. Okay. Now I would like to do some operations for my which user? EC2 user. Let me do that. HDFS, can he perform operation? HDFS plus, first of all, see who am I? This guy is EC2 user, okay? HDFS DFS minus ls slash, okay? He is able to do an ls operation. So I am trying to list, ls will stay list status, and I am trying to list what all things are there inside my root folder. So app logs, everything. What all things are there inside my user folder? User folder. It says Ambari QA. Okay. I don't have uh, the home directory for the my user. Who is my user? I am right now EC2 user. I want to have a home directory for my EC2 user. Let me create one. HDFS DFS minus mkdir slash user slash EC2 hyphen user, and it throws me an exception that it's a permission denied. And why it is a permission denied? Because it is owned by HDFS user, and I am doing this operation with the EC2 user. EC2 user is not permitted to do any operation. Then how do I do that? So first and then what I will do is since the HDFS, your Hadoop distributed file system is owned by HDFS user, so I will go with the HDFS sudo su minus HDFS. Now you see who am I, and that's your HDFS user has logged in. You can always see here also when I have logged in, it has got HDFS. Now I'll say HDFS DFS minus mkdir slash user slash ec2 hyphen user. I was successfully able to create the directory. Yeah, I can go to my UI. I can click on here. I shall refresh. Okay, it has automated EC2 user. Now you can see that, but still you see that it is owned by HDFS user. So if I go back to my EC2 user and try to create a directory HDFS DFS minus mkdir slash user slash EC2 user slash some directory by name som under my home directory. Again, the permission is denied. The reason is this particular directory, the home directory of my EC2 user, it is owned by HDFS, right? So what I have to do, again I will go enter as my HDFS user, and I will give HDFS DFS minus change ownership minus R recursive EC2 hyphen user EC2 hyphen user to user EC2 hyphen user. I will refresh this and it should change to EC2 user now. Now I go back to my EC2 user and the same command I will run, and this time it will not clip. So it has successfully created the home directory of the EC2 user, and that's my home directory, which has created a home directory just now. Okay, now in the slide I have just mentioned here, while performing the operation, if explicit path is not specified, then the operations are performed related to the user's home directory. Now, in this particular operation, I have given the explicit path. This operation, I have given the explicit path. So in the explicit path, you are saying that I want to create a directory by name home under this. Now I will not provide the explicit path. HDFS, DFS minus mkdir Shekhar. Now here I am just saying Shekhar, but I am not providing that where I want to create this directory Shekhar. So it will be relative to the user home directory. It is as good as it means that you want to create this directory under user EC2 user. This particular command is as good as you wanted to create a directory under user EC2 user. And refresh this, your UI, and you will see that it's a shaker. So that's what I was explaining you, that HDFS fs minus mkdir my directory. So this my directory will be created under user's home directory. Okay, so here you are creating it. I have just shown you how to get the directory. I will go to put command, putting a file onto HDFS. Now here, if you want to put a file from your local file system to the HDFS, you will use a put command or copy from local. So the source is the local file system and the destination is the HDFS. And the command you will say Hadoop fs minus put your source, which is your local file system, wherever, and destination would be the HDFS. Similarly, okay, so let us do that exercise. And for that, I have a Shakespeare data with me. So I'll push my Shakespeare data. Um, I will also share that Shakespeare data with you guys. Shakespeare.tar.gz. Let me share it right now. Okay. SCP minus I. Shakespeare.tar.gz to user EC2. Okay, I can go to my Ambari, right? EC2 hyphen user at home EC2 hyphen user. Okay. ls, so that's my Shaker Shakespeare directory. Let me untar it. Tar minus zxf Shakespeare.tar.gz. Now, what is the block size we have given? Let us first see that. I can go to my Ambari UI, Ambari, and I click on the HDFS. I click on the configs and I say DFS dot block size. That's is this, which is in bytes. So it is a 128 MB. Let us verify that. Divided by 1024 divided by 1024. So that's a 120 MB block size. Okay. Now I'm gonna put my file. If you see that I have just entered it, Shakespeare. You go into Shakespeare. There are 5 files: tragedies, poems, histories, glossaries, comedies. The size of the tragedies is a 1.7 MB. The size of the poems is somewhere some few KB. Histories is around 1.4 MB. Comedies is around 1.7 MB. Glossaries is a very small file, some few KBs. And let us put few files. And I'm going to say Hadoop fs minus put comedies with a file by name com. And since this is my source, that is under my current location, I'm able to find the comedies, so that's why I've given comedies. On this is my destination com. On destination, around the destination, I would like to create a file by name com. And please understand that I have not provided any specific location where would I like to put onto my HDFS. So it will again be related to the user home directory, and the user home directory on the HDFS for this EC2 user is a user slash EC2 user. So I must go there and check out my file. Under I have not given anything, so I'll say, see, this is file. You can see the block size, replication factor 3. That's the default replication factor. The size, actual size is 1.7 MB. Okay, I can also run this command like this: som slash. I have a som right here, so it will go. You can click on this. You can have a comedies file here. Okay. Now, interestingly, you can click on this here. You see this here, 1.7 MB, block size 120 MB. Of course. So how many blocks it will be? Only one block. You can click on this com, and also please understand replication factor is a 3. But there are only 2 data nodes available, so only 2 replicas are stored, and this is only one block. You can click on here, there is only one block, and the block ID is this, and this is under block pool. Okay, and this is stored on both the machines with this block ID. What I will do, I will copy this block ID. I'll go to my machine, and I know where I want to find it out. How do I know? I can, again, to find it out, I will go to my Ambari UI config. I will search what is the property which I have given where I want to store all the blocks, and that property is given by dfs.datanode.data.dir. Okay, it will not come over here, it will on the summary side of it. No, I'm very sorry. Configs, it's on here. DFS data node directory slash Hadoop slash HDFS data. I can go here and sudo su minus, and here I am, and I can search here find dot minus name. What was the block here? I can click on here, and this is the block ID. And this is the block ID which is stored. Okay, so this is under current, under block pool this, under current, finalize subdirectory 0, BLK. And if you would wish to open this, you can open this. It's a very big, you can say ls minus ltr. This will be the same size of your uh, comedies file, or 1.7 MB. But what I will do, I will say more. So you can see it's the same contents of the file I am displaying it. So it does not do anything with the file. I hope that point is clear. Okay, so that's how you can put a file. No one stops you to put all the entire Shakespeare data. No one stops you. I will go back and I would like to put my entire Shakespeare data. No one stops you. Hadoop FS minus put Shakespeare. I would like to keep on to my HDFS with the name Shakes, something like this. And I should go on to my HDFS, and now I'll see user easy to user, a folder by name Shakes has been created. You click on this and you will have all the files. Okay. Okay, now that's one thing. Now, what I want to do, I don't want my block size to be of 120 MB. I want a block size of 1 MB and the replication factor 2. How can I achieve that? With the command line itself, you don't have to change anything. You just need to say Hadoop FS minus put. Let me just figure it out once. Minus D. Okay, great. I can do Hadoop FS minus D, DFS dot block dot size equal to 1 MB. It is 10. Hadoop FS minus put, not first and foremost, I'd say minus D, DFS dot block dot size is equal to 1048576. That's your block size of 1 MB minus D, DFS dot replication equal to 2 minus put Shakespeare data with SHA12, some directory name. Okay, I can, here I will go back and enter. Here is SHA12, SHA12, whatever directory name I have given. And can you please see that replication factor 2, block size 1 MB. This time you must see 1.7 MB is the size of the file, actual size, and the block size is 1 MB. You can click on this. You must see there are two blocks. Block 0, block 1. Block 0, the block ID is this. The block 1, the block ID is this. And you can see that, yep, the two replicas are present on both the machines. Okay, that's one thing. Now,
Hello, Som.
yeah.
Actually, I got one question here. See, for this particular case, you dynamically modified the replication factor and the block size. Would it in any way affect, by default, HDFS will assume 128 MB. So when we try to read it using the HDFS client, how will it get the information that for this particular file we have block size of
When you
1
are,
MB?
yes.
I mean, do we need to mention
No,
all that, or it will take
no,
care by
no.
itself?
Everything has been defined through the configuration file. Nothing is happening on the air, right? On the flights, nothing is happening. It does not assume anything. Everything is happening with the configuration file. That's why before doing the operation, I have shown you on the Ambari UI what is my block size. What is my block size? I have shown you first, and then only I have did the operation, so that it makes it should be intuitive enough that where is that 120 MB magic word is coming up. It's not a magic number. It's where it is defined here, right? And that's why the block size is taken from here. But then I am again showing you that it is not tied to one block size. You can change it dynamically. So that clarifies you a one important question, that on an HDFS you can have a files with different block sizes. I have put some files with a block size of 120 MB, and now I have put a file with a block size of 1 MB. I can put another file with a block size of 64 MB. No one stops me.
Yeah. Uh, so actually that point is clear. Thanks for showing this important concept. My question is, when we try to read the file, because different files we have stored with different block size, how does that information come? How does HDF, the client, knows for a particular, for file A I have to read 6 blocks, assuming it has less block size. For file B I have to read only 2 blocks,
No,
because file B
I
has
didn't,
a
I
greater
didn't get you.
block size.
No, I didn't get you. Can you please check? There is one block size per file. No, what's the question?
Yeah. uh, Hello.
Yeah, I'm not able to get your question. You know that, right? From if you remember, client question you have asked me. What is that client? When I was doing the Ambari installation,
Yeah.
the client. If you don't install the client, you will not be able to do the operation. You have to install the client first. Client configurations are stored under etc Hadoop conf. So it reads that. It reads all the client. This is the client configuration. So it reads the client configuration from this particular location. So it has to get it. If you see BI DFS, right? So it has to read HDFS hyphen side XML, and you check out for DFS dot block size. So it is reading the configuration from here. I can change it here, and it will be 1 MB. I can change some value and it will take care. So that is fine. It reads the configuration from this particular location. Now, what's your question?
Actually, my question is, see, uh, like if I put a file, it will use the default block size of 128 MB, correct?
Hmm. Yeah, go ahead.
Okay, okay. My question is, assuming that I have put a file with a 64 MB block size.
64 MB
Now when
block size. Okay.
now my question is, when we try to read the file B, how does HDFS, how does the client know? Because we dynamically change the block size. When we try to read it, how does the client know for file B the block size is 64 instead of 128, so that it has to read more blocks?
Okay. Okay. Great.
I'm sorry, but
Yeah.
it's a doubt. I
File.
hope you got my point, what I'm trying to say.
File 1 has been broken into B1, B2, B3. When client wants to read the file 1 from the HDFS, he will first issue the command. He will issue command like Hadoop fs minus get file 1 to any local file, something like this. Get command. This get command will get you. When the client issues the get command goes to name node. Name node holds the metadata information of how many blocks the file has been broken into. In the question, the file is file 1 broken into. It is been broken into 3 blocks. The entire metadata information goes to client, which means that client has to read 3 blocks, B1, B2, B3. Fully stop. Irrespective of what is the size of the blocks, he has to read all the blocks to create a file. To create a file, he does not have to worry. He does not have to worry whether he has to read 1 MB file, 64 MB file, 120 MB file, etc. Is that clear? He does not have to read, he does not have to know. When he is reading, the name node will give him, boss, read B1, read B2, read B3. That's it. His job is to read
Okay.
B1 first, read B2 first, read B3 first. He does not have to care whether he has to read 64 MB, 120 MB, or 34 MB. Because the name node knows that this particular file which the client is looking out for has broken in 3 blocks. That's it, period.
Yes. Yes, so yeah, very nice explanation. Thanks so much.
Now, so get command. So you can say Hadoop. Let's say what all files are there. For example, Hadoop fs minus ls. Now see this. This time I'm not gonna use um, ls. I'm not going to provide any path here. I'm just going to press enter. So which is as good as you are saying Hadoop fs minus ls user ec2 user. So don't get confused. Okay. So but I'm gonna say Hadoop fs minus ls. Both are on the same thing. For the sake of explanation, I will also say user ec2 user so that you see the output and verify that yes, both are same. You can perform any one of those. Okay. Now I want to get this particular folder to my machine on the current location. On the current location, I have a see this. I am performing this operation on the current location. I have nothing. I will say Hadoop fs minus get sha12, that's my source, because get operation is nothing but from the source you have to get it to the destination. And on local, I want to get onto my local file system itself on the current location, so I am not going to provide any path. I say sha12 underscore local to identify. When I do an ls, it should show me sha12 underscore local. And now I can go there, sha12 underscore local, and you can see the same files with the same sizes and everything. Okay. That's one put get. That's your put operation. Getting a file. You just need to understand in the getting the file, the first will be the source, and source will be the HDFS, and the destination will be a local file system. Viewing the contents of the file. So you can also say cat command. You can do that operation to see that. You can always say the file system check Hadoop fsck. Let me do that Hadoop fsck command on few files. First, before that, I'll say Hadoop fs minus ls, and I would like to do the file system check on this particular file, com file. I'll say Hadoop fsck minus files minus blocks minus locations. That's your command. User ec2 user com. Oh, anything. Okay, it's locations. What happened? Again, not minus files, minus blocks, minus locations. I should not be able to do this. Sudo So minus HDFS, HDFS, FSCK minus files, minus blocks, minus locations, user, EC2 hyphen user, com. Oh, I am doing something wrong. Oh, HDFS, FSCK only. Usage, HDFS, FSCK path. Okay, it expects a path first. It is expecting a path first. Minus files, minus blocks, minus locations. Okay, and then it says that user EC2 user com, it's a one block. It's an under replicated. We'll talk about that under replicated later. Okay, and here under replicated blocks is 1, overlay replicate 0, minimum replicate 0, default replication factor 3, missing replicas 1. We'll talk about all this stuff later. And it says that user EC2 user com is healthy. So it's a file system check. Yeah. Okay, and then you can refer the hands-on document to do all these operations. So that's all for today. And in the next class, we'll talk about the roles and the responsibilities of the 5 processes which we have discussed: name node, data node, secondary name node, resource manager, node manager, along with the how to along with the details of reading and writing. When you say reading, it's basically how what happens behind the scenes when you do a get operation, and writing means what happens behind the scenes when you do a put operation. So we are going to understand in this module. So it's a couple of things which we're gonna do as a part of our administrative activities is like count command, which we'll talk about later when I will talk about quotas. But see that what is count command. Get merge is also one of the things which you should go for, which you should do it. Set FSCL, get FSCL are access control list, which we'll talk about later when we'll set the ACLs and on our list. Set replication factor, stat, these are fine. Creating a snapshot, getting a snapshot, uh, creating snapshot, deleting snapshot. We'll talk about that when we'll see the backup of our HDFS, how to take the backup. So all these operations are done. Lot of things. I mean, you will be doing a lot of things with this operation. There are also a couple of these are the shell commands, but you also have the administrative commands. HDFS, DFS admin. If you type this with the DFS admin, right now you have been using HDFS DFS. If you say HDFS DFS admin, you have a lot of other commands. Minus report, minus safe mode. I don't know whether I have told you or not, but there are a lot of other things. I will say minus report, minus safe mode, a set quota, set space, clear space, rolling upgrade, refresh upgrade. There are a lot of things are there. Okay, allow snapshot, disallow snapshot. Then you have a yarn RM admin. So you have with the yarn and administrative commands like refresh queues, refresh nodes. So there are a lot of command line operations which you can do it, and there are a lot of things which you can do. The first thing which we have done is a file system operation, which is again in this done a lot. Okay.
Yes, so means
Okay. Thanks. Let's meet tomorrow, and
okay.
I will upload the video by tomorrow.